Good morning. In preparation for being out Wednesday through Friday this week, I just want to do a couple of quick videos for my for all my classes. That's this one. And then I'll do a second video later that is just for first block, or at least focus on first block, for solving quadratic equations using the check your understanding stuff that I have provided today. So you need your iPad or something to log into. You can do your phone, but I highly recommend having your iPad with you. Just be aware that in the kindest ways, which I should have just done teacher, but it worked out. In the kindest ways, I can actually see who is actively logged in and actively working in this thing right here, Carnegie Learning. So you more than likely will not see Carnegie Learning up at the favorites. I favorited it because I use it regularly, but you should see it under, okay, they have moved it under Alabama Career Planning and CTE there. It should also be under the math section, but it's not. And if it's not there, okay, hopefully it's there because I don't see it, but you can always search for it as well at the very top right. So you want to go to Carnegie Learning. From Carnegie Learning, you're going to click on this portal. Yours won't have all these options. Live Lab is where I can add, and I will, while at the conference, check in on while students are supposed to be working, so that I can let somebody know if there needs to be extra support, things like that. But you also have access to your textbook through this. But I'm going to go to Teacher's Toolkit. And so everybody, all three classes, will be working on Wednesday on something. Mr. Javi will be in the classroom on Wednesday for first block. On Wednesday, third and fourth, you will be taking your linear, exponential, and quadratic functions test. And then Thursday, Friday, this is what I expect you to be working on. So I'm just going to click here. I have the same classes set up for everybody. I haven't used this. I might use this moving forward in units 1 and 2, but I haven't used it yet. We are going to pick up with this is called MATHia. This is the online component of our textbook. And so I have set up or created my own module for students specifically in the quadratic functions, and so, or solving quadratic equations. Once students have, so it's unlocked right now. Once students have gotten in, I can actually go in and look at where students are stuck. So if you send me an email at nckinney@tcss.net, I can go in and see where you're stuck. I can actually skip questions for you if there feels like there's a problem, but hopefully won't need that because we're going to be crushing it. This is the solving quadratic equations. I also, and I'll show you more about this later, I also added an additional content supplementary, right? So this is the supplement to Unit 3 for solving equations. So if you're struggling with the quadratic side, this will be there to help support you. Now, let me show you what is in here. So these are modules, as I said, that I created. This first one here, Unit 3, solving quadratic equations. We need to have for sure these first two completely done, readiness for solving quadratic equations and solving quadratic equations, before the end of this week. Hopefully you have actually started imaginary and complex, because we're going to have to test at the end of next week. So solving quadratic equations, plus also this is a massive review from Algebra 1. So I'm going to go to readiness because I want to show a couple of things. So first off, making sense of roots and zeros. There's two different types of workspaces. The first type of workspace is right here. This is a learning workspace. They call it something else, but essentially this is a learning workspace. Looking here at this, they're in a learning workspace. You can tell because at the top there's two, or not necessarily two, but there's going to be these sections here that you can click on, and it's just steps complete, problems complete. That's it. I'll show you what the other workspace looks like soon. In these workspaces also, you're going to have this information that we need to read through and make sense out of, right? So we have these two linear functions. That's the green one, right? 2x plus 4. We can see it here. we can see g of x equals x minus 3. Be careful and keep in mind, look at your axes, right? So when I look at my y-axis, it's going by 2s, -2, -4, -6, -8, while the x-axis is going by 1s. And the product gives us this parabola. And so this is important for especially what we're going to do next unit. But keep in mind that we talked about a quadratic function can be seen as the product of two linear functions, right? We're multiplying those two linears. And so if you come down, they're explaining how some of these individual points are being created on the parabola by those linear factors, right? So there's a relationship between any 3 points aligned vertically. F of 2 times g of 2 is equal to h of 2, right? So if I substitute 2 in for f, I have an output of 8. I can see that up here. If I substitute 2 in for g, I have an output of -1. Well, h of 2 is -8. We are literally multiplying the y values of those two linear functions. And so 8 times -1 is -8. So an input of 2 in my h function gives me an output of -8. And so we're going to explore this way more heavily in the future. But notice now I come over to the right side, having read all that information, examine the worked example, then answer each of the questions. How are points selected from the graph to demonstrate two factors and their product? The points are aligned vertically. Keep in mind the way this should make sense is 2 is the input, f of 2 is the output. So I'm literally multiplying the output values, the y values. And so I'm personally, you can be strategic, I'm going to look at x equals 0. And so when I look at x equals 0 and I look at my values, I see that f of x has an output of 4, g of x has an output of -3. And so 4 times -3 is equal to -12. Then I'm going to look at x equals -2. At x equals -2, g of x is -5. F of x is 0. So 0 times -5 is 0. There's -2. X equals 4. So I've got 1 times 12. And I see 1 times 12 down here. So that's x equals 4. And so again, notice they're showing f of x times g of x equals h of x. And it's how we're getting the points on this parabola. There's lots of ways to see these points, but that's a really efficient path. 1, we've got -2 times 6. -2 times 6 is there. And so that must be -3. I'm done. Moving on. Right. So notice I'm just completing this. And so if you get stuck, something to keep in mind is in the top left, there is hints. And so they can give you hints to varying levels to help you get through this. So consider this function, this equation equals 0 when x minus 2 is equal to 0 or x plus 4 is equal to 0. And you do have to enter. Sorry, I forgot about that. They'll tell you. And we know that. We've talked about that. We'll talk about it again tomorrow, today being Monday the 23rd. But that's that zero product property. The only way to get a product of 0 is if one of those factors is 0. So the first one, adding 2 to both sides, right? Remember that goes back to the roots that we studied last unit. Subtracting 4 from both sides. And these are the, keep in mind that we call them zeros when it's a function. We call them roots when it's an expression or sometimes an equation is the way they're setting this up. So 0, 0, etc. Right? So I just have to move through this and to make sense out of what's happening. Once again, they have a lot of information, which I should have used this. Notice they talk about roots here. They talk about zeros. They talk about the zero products property. So take advantage of that reading. Like this is something you can always access again in the future to help you study for assessments. Okay. That's going to be in contrast to, if it'll let me. Well, it's not letting me. Sorry. So going back to Unit 3, Solving Quadratic Equations. Readiness using properties, right? So launch workspace. So I highly recommend starting with begin step-by-step example. it's going to help us, right? So we've got this quadratic equation. And so notice this is that vertex form that we talked about in class. And so when we have that vertex form, we want to use inverses with properties of equality. So we're going to divide both sides of the equation. I will point out, I would actually use that reciprocal. And then remove the square on the left side, undo the square, use the inverse, but square root of both sides. Be aware. And so notice it's explaining how to use this. It's going to help a ton. Select a part of the expression, because when I did this, I totally skipped it and I was lost and confused, and it took me a while to figure it out. Now, granted, I did figure it out. But notice it's helping me see how it is and exactly what I want to do in each section. So I'm going to separate those roots. Remember, they're calling it roots because it's an equation. And I just have to pick each equation and I have to finish solving. Combine like terms, and there we go. Now I need to work on x minus 13. Add both sides, 13, enter, and combine like terms. And so now I've worked it through, and I can go to a problem. I'm going to do the same thing, right? Pay attention to what's going on in all these different things. Notice I did divide earlier, but I can multiply by both sides, and it's going to let me do that using that reciprocal. And simplifies for me. Now, at this point, I want to rewrite my fraction, so I get that. Positive 19 divided by 5. You didn't have to, but I would. Take the square root, right? We want to, I guess, evaluate. Thought there's a simplify radical, but there's not. And then I hate that they won't just let you leave it like that, but they're not. Yeah, they are going to make you evaluate. So I would much rather just have left that as a radical. They're not going to let you do that. For my assessments, you can 100% leave it as a radical. Rewrite the fractions, and they're going to make you go through the goofiness of separating the roots, even though you already have what x is equal to, and I'm done. Now, I mentioned earlier that there's two different types of workspaces. And so if you notice up here, it's not just filling in these circles. We actually have the skills that we need to master. And so as you work through, it's going to fill those up and you have to master them. And so like we didn't do any in that last problem of adding and subtracting from both sides. Now, I will point out it's a natural thing to say, hey, I'm adding 61, so I'm going to subtract by 61. But what you also could have done was just add by a negative 61. And so combine like terms. And so there's some things where it's going to make you go through every individual step, and it's goofy, but it's going to help you. If you want a thing I might recommend, especially because you're going to have to do this on assessments, is you're going to have to write out your work. So go ahead and do that, write out your work, and then type it in, and that'll help a lot. One thing to be aware of, you have to do the completing the square section just to get to the next stuff. We are going to approach things differently. I'll show that in the next video, but it's great. Completing the square, it's just a different thing to notice. And so I will point this out over here. This is what I do. Last unit, we just found out how to find H and K from standard form. And so completing the square is another way to do that. My personal recommendation is going to be finding that vertex form by just finding H and K. But they're going to have a huge explanation of what's going on here. And it's actually a really good explanation. So noticing, hey, we have x squared, we have this 4x, and so we're splitting it up so that if I can fill in this little region, then I get a square, right? And so notice this is what we call a perfect square trinomial because it can be factored into x plus 2 squared. It totally works. Notice it's a little bit more steps just to get to that vertex form. And so I'm going to do some problems later that show how I would just do that vertex form. But noted, oh, and this is something goofy. I'm glad I went here. They call it general form, which is weird because at certain points they call it standard form. Same thing though. But that's the one we want because we want to split it into two. And so notice they explain all this stuff as you move through. And so this is going to help you as well. But notice we had to take that 4 divided by 2 to get 2, and then we square that number. That's where that is. And so what do we get? -2, -6, right? So we can see it right there from that vertex form that we've been studying. And that's why we wanted to study those 3 different forms. And so they have some practice problems to help you here. If you don't like this, that's okay. Once again, I'm just going to complete the square, or I'm going to just convert to vertex form, but you have to get through this and it'll help you understand a little bit about that vertex form. The next thing is solving quadratic equations. Now, just be aware that with the solving quadratic equations, there's this section on factoring. This section on factoring heavily uses what I'm going to recommend and teach tomorrow in class for first block. Third and fourth, I'm going to have you work on something a little bit different that I'll show later in this video. But again, you can do step by step. You can get hints up at the top. You can do sample problems, solve it, everything you need to do. So when I look at this one thing that I would keep in mind is, I did the factoring one, right? Yeah, I did. So we're going to want to apply the zero product property eventually, but we need to factor this thing first. So I'm looking for, hey, factor quadratic. That's an option. Now, they say use this optional scratch pad here. I highly recommend it. This is going to tackle, this is a whole lot of extra information that looks a little confusing up here, but it's going to approach it the way I recommend, using the AC method of factoring, right? So the product of A and C is 10. And so, sorry, 10y squared. That is actually just 10. I don't like that they left the y squared, but I guess because they're using A and C terms. So so what we know is that we have this term 5y squared once we multiply the factors. We have the c here, but the bx is coming from these two terms here that are being added together. And so what I will now need we need factors of 10y squared whose sum is 11y. Again, we're going to talk about that in class tomorrow, but that just gives me 10y and 1y. Doesn't matter the order you put them in. It'll work out either way. And so now we just look for the greatest common factors across each row and across each column, and it should work. So the greatest common factor of y and 2 is just 1. The greatest common factor of 5y squared, they both have a factor of 5, both have a factor of y. And so up here, the greatest factor of 5y squared and y is just y. And 10y and 2 will just be 2. And so they're showing me exactly what my factors would be: 5y plus 1, because they're both positive, and y plus 2. And that's using the area model that we did last time, right? We used the area model before to go from factored form, multiplied to get standard form. Now we're getting the standard form from the area on the inside and backing out the factors is the main idea. We just have to find factors of a times c that add up to b, because that's what had to go in these corners. And now you have your factors and you can work from there. I'm trying to think if there's anything else I wanted to note. Oh, just check yourself, right? Do note 5y times y is 5y squared. 5y times 2 is 10y. 1 times y is this y down here, and 1 times 2 is 2. And so that's how I know 1, it told me that in MATHia, but I can see it there as well. I've got my factors, or I've got my factored form of that standard form. I'm going to apply my zero products property. The only way to get a product of 0 is if one of those factors is 0. And now I solve this. Now notice, again, I'd said subtract earlier, but I can also add a -1. Same thing. And just keep working from there. So I'm going to X out of this, because the last thing I want to show is this. Well, imaginary complex. I would really like for you to go ahead and get there. That's going to help you a ton next week. And everything through multiplying complex numbers, pretty straightforward. I hope I'm not misleading you, but I think every student can do that successfully. The one thing I want to quickly show is I did that supplement. There we go. Algebra 2 is stats, supplement to Unit 3. So there's this section, readiness for solving linear and literal equations. This is where I want third and fourth actually to start, to get that extra support before we start solving quadratic equations. So literally just two-step equations, right? It's going to be hard to do quadratics if we're not comfortable with two-step. So here's a great place to start. If you're comfy with this, it's literally you're gonna blow through it. So don't sweat it, right? Subtract 5 from both sides. 5x equals -7. Next step, divide both sides by 5, or as I've recommended, use that reciprocal. And you can just leave it like that. So as I said, you're gonna blow through this as long as you're comfortable with solving equations. Just remember, for that solving, we're using inverses to create zeros and ones, right? When I subtract 10 in this equation, it's because 10 minus 10 is 0. And just whatever I do to one side of the equation, I have to do to the other, so that I keep the equation equivalent, right? It's going to look a little different. So I guess I should show that, right? Subtract 10 from both sides. That 10 minus 10 on the left side is going to create that 0. Because I did it on the left side, I got to do it to the right side. Those equations right now, they look different. This 8w equals 4 looks different than what we started with. However, it's telling the same exact story. So it is equivalent to what we did because of the property of equality. And so as long as you use those properties of equality, you're creating equivalent equations. And you can use that as practice. And then solving linear and literal. So I separated this out from the rest. There's this reason from the quadratics. I don't think that you need to go all the way into the literal, but you definitely can if you feel like you need extra practice. Please do. It's going to be very useful. If you understand how to solve a literal equation, you can solve pretty much any other equation. I'll show you what we mean by literal soon. So notice this is just a more complicated version. The one thing I'm going to note in this is, if I'm solving an equation, the way I solve an equation is by identifying what is happening to my x first and what is happening last, using that order of operations. Because whatever is last, that's what I need to undo first. Now, in this situation, I actually have x's on both sides. I only want it on one side. And so I'm going to, this is not a great example of what I was referring to earlier. I'll find one in a second. I'm going to subtract 10x. So again, on the left-hand side, I create a 0. And I'm left with just that 8.5, and equals -11x. And then I'm going to multiply by my reciprocal, 1 divided by -11. And I'm done. So let's see if I can find a better equation to show what I meant. This is actually really good. So first things first here, simplifying before you start using inverses, right? So I see a 4y plus y. That means I am adding 5 y's together. So combine like terms, 9 is equal to 5y minus 6. Now, when I was talking earlier about the order, when I look at 5 and y, those things are being multiplied. So the first thing happening from order of operations is multiplying by 5. Y is multiplied by 5. Then after multiplication, we got subtraction, -6. And I'm referring to that order of operations where parentheses or some form of grouping needs to be taken care of or attended to first, always. Then after your parentheses, you take care of exponents, then multiplication and division. Remember, they happen at the same time. The order matters there, if they're together. And then addition and subtraction. And so y is multiplied by 5, then subtracted by 6. Because subtracted by 6 is the last thing, I'm going to add 5, or I'm going to undo that one first, adding 6. Now, please hear me clearly. This is not the only way to approach these equations, but I do find it the most efficient. And so I think a lot of mathematicians and math teachers would agree with that assessment. Mr. Javi, would you agree with that assessment, that it is more efficient to undo the last thing being done first?
Absolutely.
Okay, so verification from the intern. He's a phenomenal mathematician, and so we're going to go with that. All right, I'm going to find a better equation. Ooh, we got some rationals. That's what I'm looking for. There we go. All right. So I'm just looking at the so there's, as you can see, a ton of questions that you can get. You're not going to have to do all of them, but I just want to show this because especially this one. So a normal thing here for a lot of people would be actually to distribute. But the way I'm actually reading this is the first thing happening to x is being added by 3 because that parentheses is grouping it together. And then because x, or then after x plus 3, we have times -8. So you can distribute here. It'll give you the same answer. But personally, I'm going to undo that multiplication by -8 first. So I'm actually going to multiply both sides of the equation by that reciprocal. Remember that fraction bar just means division. And notice that mathematically works. I am going to rewrite my fraction as 1/4. The calculator can also do that work for you. Notice this is a simpler equation than what I had earlier, like significantly simpler. And then I'm going to subtract 3 on both sides. And in class, you can definitely get a decimal. You can use a calculator, but also this will do calculations for you on like that. But if it doesn't, just put it into a calculator. Negative 2.75. You can also type it in as -11 divided by 4. I just created a common denominator there. So third and fourth block, that's what I want you working on to start. Once you finish working through all of those, you can move to these literal equation questions. And so if you get comfortable with literal equations, then move into the solving quadratic stuff. So this literally is to help you go from normal equations that you're used to with one variable to equations with two variables. And so notice on the left-hand side, it says solve for z. Well, z is multiplied by 8, then added by 6. So I'm going to subtract 6 from both sides. Paralleling that, on the right-hand side, it says solve the literal equation for z now. It's still 8 times z plus 6. So the last thing happening, right, because multiplication then addition, is that plus 6. I'm going to subtract by 6. And so on the left-hand side, I can combine like terms. I can't do that on the right-hand side. And so I'm not going to do that on the right-hand side. But it's the same idea. Now, the only thing happening to z is multiplying by 8. So on the left-hand side, I'm going to divide both sides by 8 or multiply by the reciprocal. And I'm just going to leave it like that. And then on the right-hand side, unless the computer gets angry at me and tells me I have to simplify it. But on the right-hand side, I'm also going to divide or multiply both sides by the reciprocal. It'll take either one because it's just 1 divided by 8. And notice it even distributed that 1/8 to both of those. I'm done. Let's see. So yes, they want me to rewrite my fraction. What? You just told me. Oh, I was not even paying attention to that. So they want me to simplify that fraction. Yeah, technically, yes. Anyways, so there's all that. That is all things MATHia related. So again, if you're in first block struggling with solving quadratic equations, move into this linear and literal equations section. And third and fourth block, that's where I want you starting, is with linear and literal. And that's all I have for this video. I am about to record a video looking at some of the solving quadratic equations, check your understanding questions, to re-explain some things, but I will have that up as well soon. Come on.